All right, so I'm right now on page 6 of packet 6. So let me write that on the top so that way you guys know what I'm working on. So this is the packet number 6, and this is page 6, but I'm actually starting us off with number 3 here. So this is like the bottom part of this page, and I'm starting us off here because these problems is just asking you for the x-intercepts. So if you're asked for the x-intercepts, you are looking at where does this parabola, sorry, not parabola, I keep saying that, where does this polynomial or this curve cross the x-axis? So we can see that there are 3 points that it hits at on the x-axis. So let me highlight those 3 points. So it looks like this one here is at 1, 0. So x here is 1, y here is 0. And then this one's at -2, 0. And then we have another one at -3, 0. And so it looks like I have 3 x-intercepts here. And so in this case, the set would be this one, C. And that's it. So we'll be doing these types of problems where you're finding the x-intercepts, or sometimes they're called the real roots, up above this page. So we're now going to go into problem number 1 and try to work out some of those problems. So this is problem 1 on page 6, and first it's going to be asking you to approximate the roots. So let me just explain, your project is going to be a very similar type of setup. Let's pretend for a moment that this image, let's say that I got an image and it looks like a roller coaster. So I'm going to pretend today this is a roller coaster, and I've graphed this on Desmos, and I've plotted a coordinate plane on top of it, and so now this roller coaster is being shown on a coordinate plane like this. And so all I have to do is approximate the roots and find some other stuff. So if I'm approximating the roots, I'm looking for those x-intercepts. So it looks like there is maybe 3 x-intercepts. But actually this one's a bit tricky. So this one right here, it goes through the x-axis, so it's only hitting it once. And so it's hitting it at -3, 0. And then this one to the far side, it goes through the x-axis again. So that one only hits it once at 3, 0, +3, 0. But then do you notice the one in the middle kind of bounces off the x-axis? So anytime you notice this bounce off or reflects off the x-axis, this actually hits it twice. So that point right there is the origin. So it hits the origin 2 times since it bounces off the x-axis like that. So if it cuts through the x-axis, it only hits it once. If it bounces off, it only hits it twice. So we actually have 4 real roots here. Now let's talk about the end behavior. The end behavior, we're talking about the left and the right-hand side. So the left-hand side looks like it's pointing down, but the right-hand side also looks like it's pointing down, so they're both down. As for max and mins, I think most of you guys can see that the max here is these peaks, right, on the curve. So we can call these peaks our max because it's the highest point on this curve. And we got to name the coordinates. So that point right there looks like it's at 1, 2, -2 up 2. So -2, +2, and this is a max. Make sure you label your coordinates. And this one's also a max at 2, 2. And then we have a minimum right here, right? Because that looks like a kind of a dip or trough, we call it. And so then we have a minimum right there at the origin. Now, for this minimum, you don't have to write it twice, even though it reflects off the x-axis. You just have to write it one time, just because you're just telling me what are all the maxes and min coordinate points. So there's no need to write duplicates. Now let's talk about stating the increasing and decreasing intervals. So to do that, you're going to need to figure out is it increasing or decreasing on the curve? So again, let me let you guys imagine this as a roller coaster. So starting here, you're going to travel up this roller coaster and then onto the right side. So starting on the left side here, imagine there's a little cart and it's going up, up, up on this roller coaster. So when it's traveling up this side, it's increasing because it's going up to the maximum point. But we need to know how long is it going up. So let me grab my highlighter here. So it looks like from negative infinity, because this is negative infinity on this side, to about this maximum point, the x value is -2. So from negative infinity to -2, it is increasing. So this spot is increasing. So I know the interval from negative infinity to -2 is increasing. So I'm going to put INC for short for increasing. I also want to mention here, I did not put a bracket or parentheses yet on this -2 because I want to discuss with you guys. So when x is -2 right here, so your roller coaster cart is sitting on top of this hill right now. And you have to realize that at this point, it's not increasing or decreasing. So it's neither. In that case, you want to use a parentheses because it's not increasing. It's just sitting there. So you don't want to count that -2 to be increasing because it's not increasing at -2. It's about to basically either drop or increase to -2. So then afterwards, after -2, it looks like this is sloping down, so it's decreasing, and it's decreasing until x is 0. So if I grab another highlighter here, looks like from 2 to about 0. So from -2 to about 0, this is decreasing. And just like before, I'm going to be using parentheses here. In fact, all of these increasing and decreasing intervals, you're going to use parentheses. Then afterwards, from 0 to on up, this is increasing until we get to x equals 2. So from 0 to 2, this is increasing again. I'm going to write that over here. So from 0 to +2, it's increasing. And then afterwards, from 2 to at 2, it's going to be dropping down. So it's decreasing here. And notice how like from here, from 2 and onwards, it's heading towards positive infinity for the x value. So this here would be from 2 to positive infinity, and this is decreasing. So 2 to positive infinity is decreasing. And that's it for increasing and decreasing intervals. You're just figuring out from left to right what are the intervals that they're increasing and decreasing on. Now for turning points, let me just write the definition up here. So turning points are referring to the number of times the direction changes. And what I mean by direction that's changing is that it's going from increasing to decreasing to increasing and then decreasing. So if you look at how many times we switch, let's count them. So this one's increasing, decreasing, so that's 1. Decreasing to increasing, that's 2. Increasing to decreasing, that's 3. There are 3 times that it switches from increasing to decreasing or vice versa. So in this case, the amount of turning points are 3. An even faster way you can figure this out is if you count how many max and mins you have altogether. So the number of max and mins I have is 3. Or another person in class today was if you count the bumps or the humps here, then you can figure out how many turning points you have. Because max and mins kind of look like a hump or a bump, whatever you like to call it. All right, so now let's try out problem 2. So I'm going to go a little bit faster on this one here. So starting with approximating the roots, I'm going to figure out where does it cross the x-axis. So there's one here, 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 and here. Notice how all of them go through the x-axis, right? So they go through it, so there is no bounce here. So I don't have to worry about counting something twice. So starting with this one is 1, 2, -3. So -3, 0. And then the next one looks like it's at the origin. And then the next one is 2, 0. And then this final one looks like it's between 3 and 4. So I'm going to call that 3.5. And then if I were to ask like how many turning points there are, well, if I just count the number of bumps, there's one here, there's a dip here, and there's a max here, and then there's a min. So I think there are going to be 3 again. But I'll double check this once I figure out the max and mins. So in this case, the max looks like it's right here. And that max looks like it's at 0.5 because it only goes up about a half. And so I'm going to call that my max. And then for my mins, I have here and here. So this one looks like it's at -2 down -2.5. So -2 down -2.5. And we're going to call that a min since it's a dip. And then the other one here that's a little bit more tinier. This is 1, 2, 3. So there are 3 for the x and then -0.5. And so that's going to be a min again since that's a dip. All right, and now let's talk about the end behavior. So for the end behavior here, it looks like both sides, the left and right, are pointing up. So I'll just put right and left to be both up. And then for increasing and decreasing intervals, let me erase everything so that way you guys can see what's behind all this. All right, so let me grab my highlighter here. So it looks like on the left-hand side, this is sloping down. So I can see that this here is decreasing. So from -infinity, because we have to start there at -infinity, to about here, which is x equals 2, -2. So from -infinity to about -2, it is decreasing. Notice how the slope is decreasing. And so from -infinity to -2, it's decreasing. And then afterwards, grab my pink highlighter here, from 2 to about right here. So notice how from -2 to about +1, it's increasing. So from -2 to +1, we know that it's increasing. And then onwards from +1 to about here, which is x equals 3, you can see that this part here is sloping down. So it's sloping down, so it's decreasing from 1 to 3. And then afterwards, 3 and onwards to +infinity, it is going up, so it's increasing. So from, I think I didn't highlight this. There we go. So from 3 and then onwards to +infinity, it is increasing. And that's it. So we can definitely see here there are 3 total when it comes to max mins. So when you add them up, you get 3. So there are definitely 3 turning points here. And yeah, so hopefully that helps you out with this packet here. That's it.